Have a question. In this question we have to determine the value of force F and also find the distance between point F and point A, which is sag S, for the condition of equilibrium. So here the value of x is given to us, which is 2 meter. So first of all, let's draw the free body diagram. As we can see here in triangle BAC, as you can see, this is the point F on the segment BC. So here the concept that we are going to use, we will equate the vertical and horizontal force equal to 0 as we apply the condition of equilibrium. Now let's suppose this is the tension T1 and let's suppose this is the tension T2. So here the concept is that this tension would be equal to the weight of the block D, while the tension T2 would be equal to the weight of block E, in order to maintain the condition of equilibrium. So from here, as we know the value of tensions in the cable, now further moving by simple geometry, let's consider this distance as S. So this distance would be 4, as we can see, and this distance would be 2. So from here we can write this distance as we can see here. So we can write the value of sine theta cos theta. As we know, if this distance is S, the value of sine theta would be opposite side, which is 4 meter, divided by the hypotenuse, which is under root of S square plus 4 square, while sine phi can be written as opposite side, which is 2 meter, divided by under root of S square plus 2 square. So from here we can easily find the value of thetas. So from here we can find the value of S. Now after we apply the condition of equilibrium, that let's suppose this is the tension T1, so we can write the component of tension T1 in horizontal plane, which would be T1 sine theta, while in this side, if this is the tension T2, we can write it as T2 sine phi. So as we know, in order to maintain the equilibrium about point A, we can say that the summation of all forces in horizontal direction equal to 0. So from here, as we know, both have opposite direction, so we'll equate them, and from here we can find the value of theta and phi, a relation between theta and phi. Now after, as we find the value of T1, T2 and value of theta and phi, we can take the summation of all forces in vertical direction. As we know, the downward force is F at point A, while the upward force would be T1 cos theta plus T2 cos phi in upward direction, and this force is going to be balanced by the downward force F, and from here we can find the value of F, and also we can find the value of sag S. So let's move forward. As per the given data, we can see that the mass of block D is given to us, which is 4 kg, while the mass of block E is given to us, which is 6 kg, and the distance x is given to us, which is 2 meter. Now as we discussed earlier, we have drawn the free body diagram, and we can show the hypotenuse as we can see here. So from here we can write sine theta equal to 4 meter divided by under root of S square plus 4 square, while we can write the value of sine phi, as we know opposite side is 2 meter, divided by the hypotenuse, which is AC, length of AC, which would be S square plus 2 square. So using the simple geometries, we can find a relation between theta and phi. From there we can find the value of theta and phi, and as we find the value of theta and phi, we can find the value of force F, which is acting in downward direction at point A. So first of all, let's consider the point F here in between B and C, as we discussed, in between segment B and C. So this is the free body diagram. Let's name it as figure 1. Now let's move forward. Let's go to point A. What's happening there? Here the force, the tension in cable AB is given, and the tension in cable AC is given. We'll name it as force AB and force AC, and the downward force is force F. So these all three forces are in condition of equilibrium. So as we know, we can write the length of cable AB as you can see here, this is the length of cable AB, and this is the cable BF, and this is the cable AF. So from here we can write the length of cable AB is equal to under root of L square BF plus L square AF. As this is 4 and this is S, we can write the value of LAB is equal to under root of 4 square plus S square. As you can see, we'll name it as equation number 1. Now let's move forward. As we know, we can write the length of AC also using the same formula where length of AF is, we know the value of length of AF, that is, this is the point F. We can say it as S, and this length is given to us, which is the value of X, that is 2 meter. So from here we can easily find the length of AC. We'll name it as equation number 2. Now let's try and understand what would be the force, or we can say the tension in cable, this, as we know, BD. Here, as we know, the tension in cable BD would be equal to the weight of the block D, where weight of block D can be written as mass of block D into acceleration due to gravity, which is Z. We'll name it as equation number 3. And same for weight of block E, as we can see here. Now, as we know the tension in cables, now as we know the tension in cable would be equal to the weight of block D and weight of block E. So here we'll consider it as weight of block D, while here we will consider it as weight of block E. So first we will find their X components. So the X component of block, weight of block D would be in this direction. That would be WD into sine phi, while WE can be written as WE into sine phi, and WD can be written as WD into sine theta. So from here we can find the component. Now as we know, there are only two forces and they must be in condition of equilibrium in order to maintain the equilibrium of the system. So we can equate them. As you can see, we'll name it as equation number 5. Now at point A, we are going to consider the horizontal forces and also the vertical forces. So here, in order to maintain the equilibrium in vertical direction, we'll consider that the summation of all forces in vertical direction would be equal to 0, where we can write summation of Fy equal to 0. So from here we know the value of weight of block E, means this component in upward direction, the component of WD in upward direction, minus the component of force F in downward direction, which is F. So from here we can name it as equation number 6. Now let's substitute the value of AF and BF in equation number 1 and find the value of length of AB. That comes out to be LAB equal to under root of 16 plus S square. Now let's find the length of AC, where we can write this as S and this is given to us, which is 2 meter. So from here we can write is length of AC. As you can see here, this length would be under root of S square plus 4. Now let's first find the tension in this cable, where it would be equal to the weight of block D, where we can write mass of block D into acceleration due to gravity. Here we are considering the value of G as 9.81 meter per second square. So from here we can write the value of weight of block D, that comes out to be 39.24 Newton. Now as we know the value of weight of block D, let's find the weight of block E. So here, as we know, the weight of block E will be equal to mass of block E into the acceleration due to gravity, which is 9.81 meter per second square. That comes out to be 58.86 Newton. Now, first of all, let's determine the value of cos theta and cos phi. For that, we can write the value of cos theta as we can see here, the length of AF divided by the length of BA, as we can see here. From here we can write the value of cos theta, that is S divided by under root of 16 plus S square, while we can write the value of cos phi can be written as length of AF, as we know the value of AF is S, and length of AC. So from here we can write it as S divided by under root of S square plus 4. Now let's first find the value of sine theta and sine phi, where the sine theta can be written as opposite side, length of BF divided by the length of BA, as you can see here. So from here we can write the value of sine theta as 4 divided by under root of 16 plus S square. Now let's find the value of sine phi. This is the angle phi, as we can see here. This is the angle phi and this is the angle theta. So from here we can write the angle phi, sine phi, as opposite side, which is 2 meter divided by hypotenuse, which is under root of S square plus 4, as you can see. Now as we discussed, we'll substitute the value of WE, sine phi WD and sine theta. In equation number 5, so from here, as we substitute the value, we can find a relation for S, as we can see here. So from here we can find the value of S, as we can see, 3.4 meter. Now, as we know the value of S, we'll substitute the value of S in cos phi and cos theta and find the value of F. So from here we can find the value of F as we substitute the value of S, WE and WD. So from here we can find the value of F, that comes out to be 76.0 Newton. So here, for the condition that x equal to 2 meter, we have found the S, that is 3.4 meter, and the value of force F that is required in order to maintain the equilibrium, that is 76.0 Newton. Thank you.